department tool, but not having access or collaboration with other department. And know that it's not advised because it is very much like a closed source architecture, and which is not successful, as we all know. Like open source is more successful versus closed source, right? Uh, so it's not advised because it's very much like closed source initiative versus open source. So I believe we understand data silos word, right? Uh, I believe we understand data silos word by its meaning with respect to general production factories also. Anyway, so that was data silos. Now let's take up another term called data lake. So as understood by lake, you know how lake is formed. You know, there may be many streams or many, water waste or rainwater. All type of water might be flowing through from higher places to a lower area, and there the lake will be formed, right? So know that data lake, as the name suggests, it is a lake or a river having many streams getting and pouring water in various ways. Now, here this water itself can be, because we know water is only, one type of thing, but we can imagine this as a data. And if the data is coming from various, places, and possibly we may not be able to categorize water, but we can definitely categorize data, and the categories of data, right? So, which is structured, semi, and unstructured, right? So basically, if you will be managing all data as a global company level, and then they all will be dumped into one common kind of repository or common system, right? Universal system. We can use this word properly. Maybe if some universal system is there at across department, then that can be that system and its internal data, that place can be termed as data lake. Now, this is a side note actually. You might have known about ETL, right? What is the full form of ETL? Can someone write there? I'll just, what is the full form of ETL? What happened? Seriously, what happened? Nobody's typing. Full form of ETL. Have you heard this first time or what? I mean, I doubt. I mean, that's not so. So I would put this, as a side note, ETL. How about ERP? How about SAP? Fine, you may Google also. Yes, so extract, transform, and load, right? So this is a, I mean, existing term. You should at least know the full form, and you should understand also. It's very straightforward. You extract the information, then transform into knowledge, and maybe load. I mean, for reporting or some other purposes. Now, normally load, by load means, loading the data. You may feel like load should come first and then, extract and transform, or maybe the other way around. So please explore ETL. I'm not very much, clear on ETL. I have not worked personally on ETL, ERP, or SAP. Okay. What is the full form of ERP? Employee. What is it? No, somebody says something else, huh? What is the full form of ERP? So when it was launched, because the system was aiming to do resource planning, including the employee themselves, and many of the employees will be replaced by, computers might be, or automated tools, and hence the company people, they started telling it ERP means employee reduction planning. Okay, but that's not true, right? What is true? Enterprise. Price, I mean, yes, of course, yes, right? Enterprise resource planning. So again, this is all part of your, learning about data and information. What is SAP? So please explore, ETL, ERP, etc. Any idea what is SAP, SAP? Uh, I remember my classmate was not, into programming and fundamentals, but then he got a job in SAP, California. I mean, he got it. This is year 2008 I'm talking about. Uh, what is SAP? Any idea? Of course, you know it. It's a company, I think, right? Hmm? So SAP, I mean, is there a full form of SAP? Service Access Point? Is that the full form? I'll not Google live because I mean, I don't want to have, unfold results. Okay, but you just read about SAP too, right? SAP. It was System Applications and Products. Is that the name of the company too, or is it a tool? I mean, is it a process? What is it? Find it out. Okay, full form I'm writing as somebody typed. I am not aware of the full form. I mean, I never try to reach out for full form, but I knew that there's, companies working on SAP. Okay, and I feel like the company itself named SAP too. Like Oracle is the company name as well as maybe Oracle database. We also say Oracle, right? Learn about all this. Okay, uh, somebody typed systems, applications, and products. I'm just typing it as is. Okay. Uh, somebody started sneezing, I mean coughing. If you can please mute yourself.
Hello.
Yes,
Mm,
hope so.
Sir, there
Okay.
is an announcement for students.
Sure.
We'll have an extra lecture at 5:30 as discussed with you guys, right? So you might be knowing, but this is just a gentle reminder that we'll have an extra lecture at 5:30. So probably 5:30 your lab ends, so you can have a break of 5 minutes, and I'll be joining after 5 minutes, right? So please be present on that lecture. Thank you, sir.
Okay, ma'am. So students, you might be feeling like little funny, right? Whenever madam's lecture is there, sometimes you will hear like, guy's voice and you'll feel like, oh, who is this? What is this? And then that may be, me. And while my lecture is there, maybe ma'am will, see actually, uh, she actually informed me to announce, but there was high probability that I would miss. That's why I asked her to, do it herself too. And see, I missed, unfortunately. This is my 24th continuous hour I'm working. Okay, maybe first time, but then, or I don't remember if it was in the past. But then, anyways, okay, where am I? Okay, I just missed the spelling here, right? Anything else you may want to add with respect to, data and technical terms? Anybody is aware of any other terms? SAP is an online system to manage stock, somebody is saying. Now, fine, see SAP, I mean, read about it and explore. Maybe initially it might be the way you think, but then it might have grown, right? Because many times ERP and SAP, I mean, they are kind of talk together, okay? So explore that. But believe me, there are jobs in the market playing with, SAP, right? You might have known about it. So what my friend did, I mean, he didn't focus on any of the subject. Honestly, I don't want to name him, right? Because I don't remember the name also. But then it's his choice, right? But then he somehow, worked with SAP. I mean, he got training on how to use SAP and all, and then he had a job. I mean, right? So sometimes you have to play smart also, know your strengths, know your weaknesses, right? And get a path or choose a path or make your own. Okay. But that's why I'm taking up and trying to give you something left and right, which might make some sense and which might help you grow in your career in future. Fine. Any further topics you might want to add? Anybody? The other day I actually throwed many terms which I would have to recollect too. Anything else? Somebody? Okay, how about data factory? Yeah, I remember. Data factory, anybody has heard about data factory? or data factories, right? I think Azure and Microsoft people, those who are working with Microsoft technologies, they may know what is happening here. When I press some key, I mean, literally. Okay. Anyway, so yes, Ria, can you tell something about data factory? Because see, again, data factory is generally we feel like, oh, factory. So I mean, it will produce data. That's what we assume, right, or presume. But then it can be a product name also. I mean, it can be a product name also. Okay. So that's when I would put it. Oh my goodness, where did that go? I typed, right? I typed. I didn't save. Oh my goodness. Okay. Anyways, I'll take care of this later. Okay. Expect this material little late, um, maybe midnight. Okay. But anyway, so please explore all this term, and you definitely need to learn all these things. Okay. Data factories, please explore is, yeah, what Ria has to say. It's an orchestration tool for moving and transforming data. Right. So Azure Data Factory is actually a tool. Yes, is right. It's a software, you may say, a tool, right? Product. And we have seen in the past the meaning of orchestration, right? It lets you integrate, multiple things one after another, and then it's like a process is, together, coordinating them for data movement, right? So yeah, so why I took that up, just because all these things are, I mean, there are scopes, right? What happened to this? Oops. Okay. Fine. God knows. Okay, so what was that? Microsoft uh, Azure. Is that the spelling correct? Azure. Microsoft Azure Data Factories, I think. You find it out, okay? I'll just write data here, right? Uh, Fine. So I'll leave that topic aside now. Is I mean just to give you some more paths to move on. And there was data silos versus data lakes, etc. Fine. Any questions on that? I mean, do you want to add anything? Anybody? If not, we'll move on. Okay. Fine. So let's see what else do I got. Okay, this one small topic was left. We actually talked about compression and archival, if you remember, right? Uh, and I described also compression and archival, but then I didn't take a real-time example. Can you imagine how will you use Hadoop compression and archival in real life scenario, I mean real time, I mean not real time, but in real applications? Can you give some example where, for example, it's a cluster and compression and archiving is being used? I think I missed that topic at that time. Uh, I later on typed in these particular documents. Any guess what may be the application of compression and archival? Uh, so how to do that? I mean, it's straightforward, right? There is uh, So, and we understood the difference between compressing and archiving too, if you remember, right? Archiving is like just bundling up, but not, reducing the size. But compressing is like applying some algorithm for decoding and encoding kind of stuff and getting a smaller size. Both together is better, right? And how to do that in Hadoop is very much like, uh, is this, what is that? Uh, yeah. So you have to set a property. By default, compressed property is false. Uh, if you may turn it to true, okay, in this Java program, then, or you may do this in your configuration file also, okay, and then the output will be, instead of a regular part r, 000s, it will be part dash r dot zz. Now this zz is actually because you chose this certain codec. The default codec is, the tarball. I mean, gunzip maybe, right? This one, yeah, this particular class is the implementation of that, right? And that's why you got this .zz. And maybe gunzip is the tool which will let you extrude this. And you will be able to see similar like this file. Okay, so this was yeah. I just wanted to know. Do you think? Can you think of any real-time or real-world application what is actually doing such thing when you request a service? I'm asking, compression and archival in the area of drive, in the area of cloud, etc. The application. So I did not mention them, huh? It's straightforward. Do you remember when you try to download a lot of, selected set of files from your Google Drive? What does it do? I repeat, when you select, set of files from your Google Drive, right click and then say download. What does it do? Right. It actually tells you that there is a process started behind the scene to get you a zip file, and then whenever the zip file is ready, it lets you download it, right? So that's, I mean, that's straightforward, right? So imagine you have data sets in your Hadoop file system, HDFS, and then if a user wants to, get it into a separate local system for whatever purpose, right? Not the complete data because it is going to be big data, right? Maybe part of the data, but if user wants, your MapReduce program will, create a zip file and then let it download, right? So that's what I think I mentioned somewhere. Hopefully I did mention that utility. That utility. Yeah. Yeah, this is what I was talking about. As of date, you might have observed that online storage drive lets you download a folder containing subfolders and files as a zip file. So this is, a small thing again, but I think I missed that, so I took up today. Okay. Uh, Fine. So Ankit actually said it let us download zip file and many others also. Good that you can connect points. See, importantly, all these things, I mean, you already know is there behind, in back of your mind. But then you get to learn how to connect points. Okay, that's all about it. I mean, we teachers. I mean, we don't do anything new. We just connect points and make some sense, right? And that's what we do, right? Fine. So I think this is already shared with you in so and so lecture. Okay, you please go through that. All right. Uh, okay. So that was about the past few things which I missed. Okay. All right. So I think today's Thursday, and you got Lab 6 assignment to be uploaded by end of the day. Was it Lab 6 or Lab 5? Somebody remind me. Lab 5, which lab we have kept open? I think Lab 5 we have kept open, right? That is the custom problem statement, right? So Lab 6, I think today by end of day, you should upload Lab 6 assignment. See if you can make it. Okay, uh, and you have exam 2 weeks later or whenever, starting 24 or so, right? So know that on BDA conduit folder, I have already uploaded sessional question papers. So please do refer. Uh, we are not certain how the exam will be, right? But then you definitely, can practice that question papers. Know that BDA was introduced last year only, so you should not be, looking for papers prior to 2019-20. Okay, the BDA subject was introduced only last year. I hope you are already aware of that, right? So all those 5 sessional question papers I have uploaded. You may definitely seek uh, external question papers from some friends. You may definitely seek them. I had it once, but then anyways, you please find it on your own. All right. So let's move on. That's all from classroom for now. Few students are somehow, trying to access certain documents, and then it comes to me as a, sharing request. So if you're following anything from this Google Classroom, is not directly shared with you. I'm just utilizing, and then on a certain material, I will do file and export PDF, and that's what I share, right? And if it's an internal PDF also, I share that too, right? So you can still remind me if I have missed something, but most of your material is up there on conduit BDA folder, and don't try to refer any material which I normally demonstrate here in Classroom, Google Classroom. Okay. Anyways, uh, fine. Now, anybody started working on Cassandra? So at least if it is Linux, you please try the command called system control. Okay, learn the system CTL. Explore this command, systemctl. Okay, it stands for system control, and it is actually for administrating many things. It's a common command utility. Uh, I think RHE 6 plus has this system control. So, or try some others, corresponding commands. But I barely remember it was Cassandra only when we installed that on one of the computer of our C department, and then the computer was very slow next time onward. So I was informed by Bimani sir that because Cassandra is very heavy and likewise like code. But I said I don't need it every time. I mean, I will need only during 1 or 2 labs. Student may want to use it, they may start it. What a big deal! But they say there's nothing like starting. I mean, he couldn't completely justify why it is heavy. But then I figured out that it was actually configured as a service. It was installed via maybe yum or apt-get like internal commands. And while installation, they were configured like the service itself was configured to be start automatically. I mean, the service as active. There will be something like enable, disable, active, passive, specifically enable, disable, and active. So I realized that the service starts every time, which was taking up a lot of memory and computing. So I ran this kind of command like system control and maybe service Cassandra disable, something like that. And then what happened, I could also check the status. Next time onward, when the computer will start, the service will not start by itself. Hence, this computer will work, normally. I mean, not like overloaded. Okay. So such stuff you will have to learn. You will have to, do tuning. You will have to understand what can be the reason if your computer is not performing well. I do that with my MacBook every damn day, and that's why I'm able to, still at least cope up, even after 10 years, right? Anyways, so please learn all these things. That was again one of the side note. So let's move on to other topics. Is my screen visible? I don't know. Okay. So we'll first go to MongoDB architecture. We had few topics left there. So please pin please pin one of my presentation from MacBook if you haven't done so already. Uh, at least on my phone, it's not displaying right now. Are you able to see MongoDB architecture guide? Please type in yes. Okay. Somehow my phone screen is not refreshing, but I'm fine if you can see it. Fine. So I have already told you from official MongoDB website itself I have downloaded this particular white paper, so-called. It's, I mean, very plain. I mean, not much detailed. But then you can definitely start here, and uh, we took up few things from here already, and you will see now, a few terms like data lake, uh, uh, used in such white paper official by MongoDB, right? So that's when you should be aware of technologies, technological terms, right? Fine. So I have highlighted a few text from here. I'm not gonna read all of this, but let me. Uh, I mean, few of these we already described in the past, but few were missed. So I hope that highlighted text is still there. I did that, and I don't remember did I save it or not. I never tried editing PDF because PDF used to be, always read only. But then there are tools, I mean, which let us highlight and maybe save and do a lot of things. I never tried that. You can still explore. There was one of the reason you all were asked to upload docx file because in Google Drive Docs, you can write comments on a doc file. That what I assumed it was working. But one day in maybe third sem, one student uploaded a PDF file because the constraints were not in place in the subject of DBMS. And then really didn't realize that I'm, putting comments on PDF. And then I also shared back. And then later I found that it was a PDF file. So then I thought like I should explore this. Originally, I thought like this is all proprietary or I will have to pay and all, but it's not the case. Please try exploring all this, uh, uh, PDF features also. Let me see if my highlighted one long time ago and if I would have saved. Let me see if it is still there. So it's not there. So I doubt it's there. No, it's not there. Okay. If you remember, we were talking about MongoDB, and I told that one of the diagram by Pinkelman showed that MongoDB is on which side? I mean, out of the cap, which side was that? Uh, So partition tolerance is definitely going to be there, but out of consistency and what was that? Out of consistency and availability, what does it support? I mean, what does it opt better? Yes, answers. Do you remember or forgot? See, your exam is still due, okay? Don't start forgetting stuff. Uh, so Cassandra is on which side? MongoDB on which side? Okay, I'm asking MongoDB falls under, is primarily focusing on which part of the thing? I mean, consistency or availability? As per, one of the slide by ma'am, I think. So Ria says MongoDB is CP. Now you will also see, on web there are debates that don't just say CP or CA, etc. You find out why they are trying to, convey that message. Don't say CP or don't say CA, etc. But just to, for a beginner, it is good to at least say that Mongo is a CP. So there, the partition tolerance definitely is there, but then consistency was right. Focused. So this particular paper actually has that, one few lines which talks about consistency. That's when I actually highlighted that, and I wanted you, let you know officially that MongoDB is actually after, consistency first, then availability. It also is, nicely available, right? But it is still saying consistency is more having more priority over availability. Oops. Oh my goodness. I'll drink a water. Wait a minute, please. I mean, I'll drink a glass of water. Oh man. Or else you please download this MongoDB architecture white paper by MongoDB website itself and read through. I mean, that's just, a smooth read. Okay. Um, I'm still looking for, that, yeah, here. Are you all able to see this para, right, which says with strong data consistency, MongoDB eliminates the application complexity imposed by eventual consistent NoSQL systems. And we know what is eventual consistency, right? BASC, I mean, basically soft, eventual consistent, right? We all are aware of gap theorem, Bayes theory, etc., right? So this particular excuse me, this particular paragraph tells me that it is actually, maybe a CP type of database. Okay, but it's not saying that we are compromising availability. It's not saying that. Okay, so read through is fine. Now we'll take up another topic called shards. Okay, again it's a small theory here, but then the other day I showed you what is a shard, right? Let's say there is 1 terabyte of data, and if you partition them into four, 256 GB each, then you are saying you have four shards, and though the four shards maybe maybe on different computers, right, different nodes, but then logically it's all single for you. So shards basically sharding techniques is very much like partitioning, right? But then it actually the MongoDB gives you a choice of what? Let's just see where is that shard? Let me just hold it out. So, yeah, one more term actually, because before we go further for sharding, I would expect you to learn this particular term, resilient. Okay, I mean it's been used in industry widely nowadays. So please, be familiar with this term called resilient and try to utilize for your better future. Okay, resilient. Okay. Anyways, sharding we were talking about. Oh, okay. Here. This is what I want. Come. Okay, so from the official white paper itself, uh, right? So MongoDB let you have multiple sharding policies. You remember, like consistency, there are levels you can choose, right? That way, I mean, in general, consistency levels are there, and administrator can choose it. That way, at least with MongoDB, there are policies available for sharding techniques, and there are more than one, and the administrator can choose which one he wants to utilize. So let's understand various sharding policies, right? Uh, uh, the MongoDB offers for better approach, right? Data can be distributed according to query patterns or data placement requirements, okay, giving you much higher scalability across a more diverse set of workloads. This is one more word you would like to, have it in your dictionary for sure. In interviews, try to utilize these words, okay, like workload, resilient, etc. Right? Do understand the meaning of workloads, okay? Try to figure out what exactly workload, where all, in which all contents can you use the word workload, okay? Um, so I'll keep that for you. Okay, resilient and workloads. I mean, explore and do utilize it in your technical talk. Okay, so it's saying that for diverse set of workloads. I mean, it's very much like diverse set of requirements, right? Uh, for storage and accessing, right, and querying, etc. Right? MongoDB gives you this, sharding policies, and they are these three. Now, yeah, I mean, it's very obvious that this is a theoretical topic, right? So I may be able to, frame 2 marks question very smoothly, like describe sharding techniques or sharding policies, supported by MongoDB for diverse set of workloads, something on those lines. I mean, it's all here. All you need to do is read, understand, and reproduce. Yeah, you will not really need to apply a lot of brain. But yeah, of course, you can go in depth, and then you also can learn how to configure this, and maybe you prove that it is working the way you want, right? So let's talk about sharding policies. Uh, Pardon me on the pronunciation of shard. I mean, I was stuttering while I was a kid, so you try to speak this properly. Don't just follow me on that. I still stutter sometimes. I mean, when I'm not confident. Okay, so I learned that when I grow up, stuttering is actually possible. Maybe not just a physical fault, but maybe if you're not confident, uh, that is another reason also when you stutter. Anyways, yeah. So I'm right now not confident how to pronounce this particular, though I have used extensively back at work in 2010, right, to 2012. Anyways, so ranged sharding, then hashed sharding, and zoned sharding, right? So it's very much like if documents are partitioned across shards according to the shard key. Now, right? Then now this is shard key value, so it's a little confusing, okay? But that's white paper by MongoDB. I mean, understand how you do, okay? So document with shard key values. So is it a key or value? I mean, what they are focusing here? If you want to really read the contents, is it a key or value they are focusing? They are focusing value, okay? I hope you understand what I'm trying to convey. Are you really able to see my screen? Are you able to see range sharding, hashed sharding, and joint sharding? Because I'm not able to see on my phone. I don't know why. I might have to reconnect, but you are able to see. That is good. Okay. So ranged sharding, I mean, with values, right? The documents with shard key values close to one another. This is really tricky, okay? This key value means, will that be a key value pair? And is it talking about the key, or is it talking about the value, or is it talking about the value of the key itself? This is really tricky. Okay, what do you think? Is it talking about the value of key itself? I mean, key itself. Yes, yes. This is tricky. If you may read, you will That's when I think I mentioned to somebody saying read the book more than once. It may make more than one senses. I mean, it will give you more insight, right? So yeah, it's actually key only. Okay, the value of the key itself. I mean, the information which is hold there in key. Anyways, so see why would we judge that? Because we are talking about partitioning, and we know we partition based on keys, right? So I'm just talking about key. Anyways, so documents with shard key values close to one another are likely to be co-located on the same shard, and this approach will be well suited for applications that need to optimize range-based queries. Now you understand range-based queries, right? When you say give me information between 10,000 to 20,000, that's when I say range. If I say give me information of all the cities in the state of New York, then I'm talking about a range primarily, right? So such queries, if you may, try to store data partitioned based on the key, then you would like to choose the range sharding tech as one of the policy for MongoDB sharding, implementation, right? So, I mean, can you choose more than one? It's a question mark, right? Or you have to stick with any one of these, right? Or can you have, as per the query that other day, ma'am throw a keyword, what was that? Query driven document, what was that? Query, what was that keyword? Based on the query, you design your, storage of data. What was that keyword? Anybody remember? Based on the query, I mean, you design your data model. Uh, Nobody remember? My goodness. See, I learn new things out there. Why would you not? So it's just that the name you don't remember? Anyways, so basically, if you have application where you are, primarily hitting range-based queries, you would like to, configure the sharding policy as ranged. The other one will be hashed. Hashed, we know hashing some, MD5 hash or some kind of hashing you. So, which is open optimal for ingesting streams of time series and event data. Now, we have not yet talked about time series or event data, etc. Okay, but you start exploring this part, okay, time series or event data. I think will machine learning focus on time series data? Any application of machine learning focusing on time series data? I mean, would you know anybody? Machine learning focusing on time series data. Any application you may know? Okay, maybe not. Fine. But yeah, these are a few more. So sales prediction, stock price prediction. Yeah, stock price we can definitely say yes. So time series is very much like streams basically of time series and event data. So analyzing climate change, yeah. Then there is something called rare events. So I post that in high level aims. If I would have shared with you high level aims from Google Classroom towards the end of this subject, or maybe sometimes I'll keep updating Google Classroom, and I will show you the um, high level aims. Mean to say, what best can you achieve, or what best has been achieved uh, with the use of big data and analytics. One of them is detecting rare events. Let me write it because I'm not able to move my screen. Detecting rare events. Now, does it make sense? I mean, you might have either, a data lake, data warehouse. I mean, you might have, stable data, frozen kind of data, or you might have streams of time series or events. Your job is to detect rare events. Now, this is one of the application we are talk as of now, and we have talked many applications, right? And this is one more. I would make one of the document also on this detecting rare events. That's one of the vast application. This is the general name, detecting rare events. It can be applied to any damn domain, right? And you will have to term it under the umbrella of detecting rare events. Okay, it's very much like the climate. What Ria mentioned. I mean, if you all of our life is normal, right? But then when will the earthquake might hit? So that might be a rare event in certain location, possibly, right? So please explore this one more application also called detecting rare events, right? Fraud detection is also kind of one more application. Anyways, moving on, uh, the last sharding techniques uh, is based on zone. Okay, it provides the ability for developers to define specific rules governing data placement in a sharded cluster. Now, can someone give me some real time or real world made up application scenario? When will you choose zone sharding? You understand the meaning of zone, right? Zone, right? Oh my goodness. Ah. So it says that you would actually, maybe there is a diagram also, if I could show something. There is a diagram also which talks about, yeah, here, right? See, this is like zone 1, North California, zone 2, North Virginia. This is where I was working for almost 3.5 years. Okay, and this is zone 3. I've been to zone 1, 2 also, Frankfurt, Tokyo, and zone 6, Sydney. So basically, you would want your shards to be zone wise, okay, zone wise, right? When would you want this? I mean, uh, any particular application you might want. Of course, it's for availability, data centers, replication, etc. We are talking, but I'm not expecting that answer. I'm expecting a different answer. When will you choose John sharding policy? It provides the ability for developers to define specific rules governing data placement in a sharded cluster. So basically, you know nowadays, maybe Zoom or certain applications are facing, see, I'm not good at, understanding news, so don't just follow what I'm about to say. I might have, interpreted it incorrectly. But then we feel like there's few applications in the market which face problems because they put their data into certain part or certain zone of the world, right? Then they have to actually, come up with policies to meet, government requirements, right? And they will have to, originally, if they might be storing data, maybe range-wise or hash-wise, but then they might have to switch that sharding policy to be zone-wise. So what would happen? Any data which is being, created by, let's say, people of Asia, those data will be kept in shards which are actually in the zone Asia. For example, any data which is generated by Northern Virginia zone 2 people, they will be stored in the zone 2 data center itself, like those shards. Okay, so such that is the third policy which is being implemented by MongoDB, and it's talking about zone sharding. So see, this is basically a theoretical topic, right? I can ask for 2 marks, but then it's there in your architecture. So I thought I should take up, and it's yeah. So Jainik is saying data localization, right? Now. Please explore this data localization. I mean, it can mean that you will store data locally. It can also mean that you will have your code on a computer where the data resides, okay, and take benefit for the speed, not to transfer the data from one place to another place. So data localization, I mean, don't confuse yourself to use this term. Read more and understand the contents and then try to utilize. Scenic is okay. I mean, it's not a wrong word, but then it can have, multiple meanings. And then we have to stick with, the majority of people, what they understand by this particular word or phrase, data localization. Okay. But yeah, I mean, you basically understood, right? Whichever data you generate, it will be there in your, Asian continent. So that way, this, localization, etc., makes some sense. But together, data localization has a little different purpose where they take benefit of locally stored data for performance sake. Okay, fine. Uh, Now, yeah, Vivek is typing something about latency. So this one more term also technically you should be aware. Actually, there has to be one, versus in our Google Classroom, like high latency versus low latency systems. Uh, think I should add that. Uh, it was there on my, to-do list, but I never got chance to think again and put it here. Yeah. So what about what is it? High latency systems or low latency system? Can someone narrate that? Uh, what do you exactly understand by latency? I mean, am I pronouncing it correctly? Hopefully. Who really understand uh, high latency versus low latency systems? Come on. My goodness. Oh, high latency. Oh my goodness. I'm literally tired today. Versus um, low latency systems. And it has to do with it has to do with I think cat theorem also. I mean, it can be connected to any damn topic appropriately. Okay. So please explore that high latency versus low latency system. Okay. Uh, so latency, somebody is trying to explain. Vivek says it reduced latency, reduced delays, faster response. Okay, so low latency means you will expect faster response. Is that correct, Vivek? When I say low latency systems, that means you care for faster response. Okay, so if I make my statement again, if you say low latency system, that means you care for faster response. That means out of cap, what would you go after? I mean, would you go for consistency? If you need faster response, I mean, can you really take care of strong consistency? Uh, See, if you remember, write to multiple replicas, there are, uh, ma'am is actually taking up this topic, but I follow her lecture just so that I can connect points, to you in a different perspective, right? So, if you remember, when write mechanism, etc., talked in, her MapReduce and other Cassandras everywhere, right? So if you are just making sure that at least two copies are good, then you actually, conform to the writer saying your job is done, you may move on. That's what called faster, perform faster response. But then the behind the scene, out of 5 replicas, for example, only 2 were completed, but 3 still have to be, complete or synchronized. So that will happen behind the scene, right? That's what BASE, basically available, soft, whatever, right? Eventual consistent. So in a latency system, basically I cannot expect to have strong consistency. That's what my point is. Do you all understand what I'm talking? In a low latency system, oh, okay, again, low and high, I mean, you have to understand latency itself. So low latency means faster, what is it? Faster performance, right? So low latency means high availability. Oh, okay. I myself would have to clarify on this because latency, when you go with low and high word, it has its own meaning. You have to understand what it is. Vivek, what if we were to say is RIA? So low latency means high availability. Yes, means performance, right? I mean, it should, in Vivek's words, what was that? Faster response. Okay, high availability or faster response, right? If it is, I mean, it's not high availability. Can we say high availability means faster response indirectly? Because see, if it is available 1 hour later, we cannot say it is available, right? So high availability can also mean faster response, right? So yes, low latency means faster response means high availability. And if you would want that, of course, availability is one angle side, right? One triangle side. The okay, Vivek, am I going on the wrong way? I mean, you just said no, right? Anyways, that's a side note. Literally speaking, I really don't have, we will have more topics to cover also. But today and many times I, try to touch left and right here and there. Okay, so explore low latency and high latency. I will throw that to you. Let me see what I had on my hood today. Uh, yeah. Oh my goodness. I thought I will take up. Anyway, we have tomorrow lecture. But Hive, we'll take up Hive tomorrow, okay? So one lecture we'll take up Hive tomorrow because on Monday we'll have lab on Hive. So by the time you to, install and all, just to throw very quickly, Hive actually stores data into HDFS, but metadata into another RDBMS system like, what was that? What was that? DB. Yes. You can also choose MySQL. Let me just throw this very quickly. Understand that Hive stores data into HDFS and metadata into a separate RDBMS system, which by default is DB. Okay. Anyways, I think I have shared this already in under Lab 6 header. You start, at least installing Hive. A few of you already requested to share this document to me. I mean, did you get that document from Lab? I think that was Ria only, or some other girl and boy also. But know that is it available? This Hive QL, is it available on Conduit BDA? Okay, okay, good enough. So all of you, explore this to install Hive. You will definitely learn a few more things out of it. but then you try to use this for how to install Hive. Okay, you utilize this particular Lab 6 PDF from Hive. Okay, so sounds good. Actually, I opened another PDF. This is last year PDF when lectures were taken, and there were proper 4 week and then sessional, etc. So if you remember, I mentioned data modeling, right? So that's what one more topic. Anyway, we'll be taking up. Uh, so I have not been given any instructions that what will be in syllabus for your sessional. I mean, will that be 4 weeks, 6 week, or 7 week? Because at 24th, I think will be at seventh. I mean, this is 6th week, and next week is also we are teaching. So 7 week will be completed, right? But then the exam is after 7 week. But I'm not yet, having any answer on what will be your syllabus for the exam. But you keep preparing, okay? You keep preparing, and you have the material. But I was trying to match, previous year topics covered with this year, and then I came up with. Few one important thing is this: what is data model? Okay, we'll be talking about big data modeling and management. And if you remember, I keep telling you that the way you do uh, data modeling in your machine learning in big data also is very much like storing data and accessing, but then it's turned to be data model. Okay, so we'll see to that. Fine, I'll let you continue. Okay, thank you very much for your time today.
A very good afternoon to all. Lab 6 material, the dataset is already uploaded on the Google Drive. So just download the dataset and then we'll begin the discussion. Today, the focus of the laboratory is on logistic regression. And yes, before starting all the discussion, am I audible? Yes, right. So the class label Y. And I hope it's an binary classification, right? Y or N. So in today's laboratory, we'll focus on the logistic regression and what I have planned for this lab as well as for the next lab also. We'll focus on this logistic regression itself. The reason is over here in the lecture we have introduced the softmax, right? So that is the one thing. The second, the sigmoid function that we have seen during the lecture session is also an important activation function. So most probably from the next lecture onwards, we'll start the neural network where we'll refer this whole term activation and the perceptron and the neuron and so on. So this is a very important, very frequently used the activation function. So that's why we want to focus on it more. And the second reason is, or the planning is, as we have discussed in the previous laboratory, we'll try to cover TensorFlow as well as the PyTorch aspect of this particular model development, right? And in a previous laboratory, we have seen the PyTorch version of our linear regression. So today, first we'll see a basic version of logistic regression, where we'll just use the NumPy, Pandas, and that open libraries, no TensorFlow, no PyTorch, nothing else. Right? And then in the same laboratory, we'll see an implementation with sklearn library. Right? So we'll see two different versions. One is without any library. The second version is with sklearn. So hope you have downloaded the data set. And yes, in the next laboratory, we'll see once again we'll see the logistic regression, but at that time we'll see it with maybe with TensorFlow or PyTorch, right? I will pick one of them. Right? So that will be the flow for current as well as for the next laboratory. But before moving forward, I hope everybody has downloaded the data set, and let's just revise what we have learned so far and what exactly you need to do whenever you try to develop any algorithm, neural network based algorithm. So we are focused on three things: first, second, and third. So the first thing is the hypothesis, where the hypothesis value over here is bit different than the hypothesis that we have used the linear regression. Right? So in the case of logistic regression, what's your hypothesis? One upon 1 plus e raised to negative z, right? Where z is actually, you can say, theta transpose x, right? Or you can say the multiplication of your weight and the x value. Previously with the linear regression we just had theta transpose x, but right now on the theta transpose x we are applying some operation, and to be specific, that some operation is actually a sigmoid operation. So on the theta transpose x we are applying the sigmoid operation, and lateral with the neural network will refer that operation as an activation. Fine. So that is the first thing, hypothesis. So in our case the hypothesis is the sigmoid function. Next step is, once you have the hypothesis, you can predict the answer, right? So once you apply this particular hypothesis on all the data, so for all the particular data value, you have prediction result. Fine, and you can set some threshold and the answer. And right now we are just focused on the binary classification, right? In the lecture we have discussed that you can convert the binary classification to the multi-class classification by simply considering one versus all phenomena. Fine. So using that, you can classify your data into one of the class. Let's say the class labels are 0 and 1. So your answer or your prediction is either 1 or 0. So once you have the prediction result, the next step is you need what? Can anyone recall the second step? So the second step, we need to find how the prediction is different than the original value, and which laws we'll use in this calculation. right? The logarithmic loss, right? The loss function or the cost function, right? So it decide how the overall prediction for the training set, whichever prediction that we have done, that overall prediction, how it is different than the original answer, right? So based on that loss calculation, so that is the second step. Now we'll try to update our parameters or our weight values. So for that, which is the third step? To update the parameter or to update the weight, which steps we have used. So there are many ways, but out of that ways, we have chosen a particular way, which is most probably you can say it's version, that is a gradient descent. So using gradient descent will update the parameter. And so these three steps we are supposed to follow. Fine. So now if you just open your data, if you just look at your data set, the by computer data set. So which one is the Y value? Purchase, right? And how many X values we have? Right. So using these two X values and with purchase as a class level, so only, right? So you can just on further process the value, and you also can use the as estimated salary. Use data, try to apply logistic regression into the code. Some code I already in the first file, while other code you to complete to fill, and some will discuss the answer so when verify your current answer, right? So keep only three things in your mind. The first is hypothesis, that is implement the sigmoid function below. Once it's upgraded, and if you want to refer, the lecture material is already shared in the Google Drive, so you can also refer the lecture materials from the drive. Okay, so just start the implementation, the logistic regression on this by computer data set. Are you getting what you are supposed to do? Meanwhile, you can post any query if you have some query in this logistic regression or maybe some other query. You can post it in the comment section, so all other can see, and all other, if any one of you can answer, then we should have a discussion on that too. Right? I hope the steps are clear. So if you see that eventually starting from the first lab, in the first lab I have given full material, right? The laboratories, the full implementation of all the programs. Lateral, lab by lab, we are the content that I am giving to you, that I am reducing, right? So that your work, the implementation work, will definitely increase. But I will make sure that at the end of laboratory, I will at least display the content, as well as I will explain that content, so that if some of you might not get how to implement that particular version, then at least they can see the code and they can copy the code. Shall we begin? Okay, so let's start the discussion now. I hope my screen is visible as well as the audio is proper. Is it so? Okay. So I hope up to this lab you must aware about this Google Colab upload. If you want to upload the file, you can just use this particular code, right? And we have converted that particular data into a pandas data frame, right? And eventually we have removed the column user ID. Why? Because that particular entity is unique for individual buyer and there is no impact of that user ID on the output prediction, right? Or there is no influence of that on by computer. So if you observe some of the data, it looks like this. In the Y, we are considering first and the last column. So that means I need to remove the first two entry and I just need to focus on the last entry. So -1 indicates the last and the column over indicate all the row, last column. Right? In the reverse logic on the data X, where we are considering this age as well as estimated salary. This our very favorite and you can say very popular function, train test split, where we are supplying X and Y value. We are setting the test size as 0.25. That means in my training exam, in the training, we'll have 75% data and remaining 25 we are keeping for the testing purpose. And the random state data I have set is to 0. You can update that value too. And the output that we'll get will be X train, X test, Y train, and Y test. Right? And what is the role of this particular cell? Just see the code and can you identify what exactly the role of this cell? Scaling, right? We are doing this feature scaling. Is it essential? Specifically for this example, is it essential? Yes, Chainam say yes. Devang also say yes. Muktan, yes. Why can anyone tell me what should be the reason why it is essential for this data? Yes. So if you see age and the salary value, and also if you check the range, so there is a very huge difference between the range of age as well as the range of salary. Fine. And eventually what happened, whenever you apply that theta transpose x, no matter whatever is the theta value, the high impact, or you can say the high weightage, will be towards the salary. Yes, correct, Muktang. Are you getting why that scenario will happen? Because what will be our initial equation, theta transpose x? Theta 1 x1, where the theta 1 is some weight and the x1 is the age value, plus theta 2 x2, where theta 2 is once again some weight and x2 is the salary value, right? So now if I just keep it as it is, what happened, the salary value are already very higher compared to the age. So let's say if the theta values of that salary is lesser, even though that multiplication result will be higher, so you can say it will have the high influence in the answer, or you can say there will not be any balance influence of age as well as the salary. Fine. So that's why it is advisable to apply this scalar operation on the data whenever the range is or whenever the difference of range is very large. Fine. So on X train as well as on the X test, we are applying that standard scalar. Right. If you want, after this particular line, you can just print the answer. What exactly the X value before this operation and what exactly the X value after the operation. Fine. Now next, some calculation or some variable that we will use for the sigmoid function. Y predict will deal with the prediction results. So we are creating that empty set. Then the length of x will actually, we want to identify how many x values we have. So right now we have 2 values. So the answer of that will be 2. And w once again the empty, and bias we are setting to 0.2. Right, you can once again the initial value of that w as well as b, you can perform some trial and error and you can try different values of that bias as well as weight. And in the training we have total 300 examples. Fine. And we are setting weight values to 0, bias to 0.2, and weight value are 0. Initial weight values are 0. Now just focus on this cell, sigmoid function. So we know the equation, it's just 1 upon 1 plus e raised to minus z, right? Where the z is your hypothesis. Fine. So we have just created the sigmoid function. So the role is, whenever you call the sigmoid function, what you should supply? You should supply the hypothesis value. Fine. Rather than hypothesis, so we are treating that sigmoid as an activation. Fine. So before that sigmoid calculation, what we need to multiply weight and the feature. So now if you consider this predict cell, we are applying the dot product between weight as well as our feature, or you can say the input, and also the bias term. Fine. So that is your z value. So we are calling the sigmoid function with this result, that is the z value. Fine. And sigmoid activation will give you a value a. So what will be the size of this a? Will it be a single entity, or it will be a vector or matrix? If it is a vector, then what's the size? If it is a matrix, then what will be the size? Right. So you have the examples, you have the numbers. So just try to print what is the size of this a. And so just if you haven't implemented up to this part, just copy this code and tell me what will be the size of this a. right? So Darshan says that it's a vector. A is a vector, and the size of that A is similar to the size of Z. So what is size of Z? So you have numbers, right? So your answer is correct, Darshan. But I need the number, whether it is 300 to 500 or something else. Vivek once again said that it's the size of white rain, but I need the number. So you have the code, just try to print that value. $300. Fine. So you have 300 different results for A, and also try to print the values of A. Maybe you can print some initial 5 or 10 values, or if you want, you can print all 300 values. And can you tell me what's the range of that A values? Okay, so for this answer A, what is the range? If you consider any element, let's say out of the 300, if you just check 5 or 10 elements, what's the range of that 5 or 10 elements? Are you guys really implementing this stuff, or just seeing the code? Even if you do not implement this stuff, and if you just see the code, then also I guess you should able to answer what exactly the range of A, if you are clear with the lecture concept as well as the particular function. Right. So it's in sigmoid function, so the range must be between 0 to 1. Right. And we'll consider that range as an probability value. Fine. So accordingly, you can consider a particular class. So we have true values. So that is the y train value. And we have this A value that you can set the prediction value. Fine. So now what's next? Loss, right? Or the cross entropy loss or the log loss. So the loss function is simply y times log of a plus 1 minus y time log of 1 minus a, right? And we know that it's a negative, so that will be the negative value. And many times people refer this particular loss as the cross entropy loss. In a lecture, I have just given that particular term cross entropy loss, but if I just spend some time over here, why it is referred as a cross entropy loss. So for that, you need to recall our discussion of decision tree, where we have introduced the entropy. And the equation of entropy is, let's say, minus a log a, or to be familiar with this terminology, minus y log y. or you can say y log 1 minus y. Right? Both means the same thing. In that case, that is in the case of decision tree, we were focused on the count. We have original count as well as we were calculating from the training example, we are calculating the count which belongs to, or you can say the sample which belongs to particular class. Fine. So that's why y, and you can say the log y. So both terms are related to the y. And if you recall some more concept, why we have derived that equation y log y, that is from the parameter of surprise, how much surprising the event is. So if the surprise value is high, the entropy is high or less. Entropy, remember that we are not focusing on the cross entropy right now, just the entropy. So if you just recall that decision tree discussion, if the surprise value is high, the entropy value is two option, high or low. Devang say less and Mayank and Jainam say high. Anyone else? Any other answer? That means either high or less, right? We will not have any third answer. Once again, it's in binary value. Fine. So just recall that lecture, and examinations are near. So you will definitely recall that lecture and refer that once again, whether it's high or less. But the point over here is, in the case of cross entropy, what happened, that surprise value that you are predicting, that is different than the true value, right? So if you just focus on this equation, the log equation, it is similar to the equation of your entropy, right? Once again, we have the minus sign. So let me just rewrite this particular entity. So you can say it is minus y log a into minus 1 minus y log 1 minus a. And let's make it more simpler. And if I do not consider the second half, if I just focus on the first half, so over here you have two terms, one is y and another one is a, where we know that the y is the correct class value and the a is the prediction. Fine. So if I change this equation to minus y log y, then it's an entropy. But over here, we have y value and the expectation that we are considering is on a. That is the prediction value. Fine. So that's why it is referred as the cross entropy, where it's a cross relationship between this y as well as the a, or you can say the cross relationship between the original value and the predicted value. Or the y is the original value, or you can say the true label, and the a is the predicted. Fine. So this loss function that we are using over here, you can refer it as an log loss, or you can refer it as an cross entropy loss. Right. So now next we have an alpha value. Let's just set an alpha as 0.1 and recall that alpha is actually a hyperparameter. That means you need to tune the alpha value. Yesterday, I just whenever I was reading one paper, I just like to share one experience. In the lecture, we have discussed that we should not use a squared error loss over here, and we should stick to this cross entropy loss, right? But eventually, what I found yesterday, whenever I was referring one paper over there, they have suggested that you can use. Okay, what was the reason why we haven't choose that cross entropy loss? Sorry, why we have choose this cross entropy loss and why we haven't considered the squared error loss with this logistic regression? What was the reason? Can you just recall the lecture? Local minima problem, right? So to avoid the local minima, or you can say to get the convex graph, we have considered this cross entropy loss, and we have avoided that particular scared error loss, right? But what I found that in one of the paper, they have argued that you can still stick to this cross square error loss, but what you can do, you can keep the alpha value, that is the hyperparameter, bit larger. So what will the advantage? We are using the square error, so we'll have the local minima values, right? But as the alpha value is large, what happened to the jump? Larger jump or the smaller jump? Larger jump, right? So even if you have many local minima, there is a very high probability that you will skip that local minima thanks to that larger jump. Right. But we know that there is one drawback also. Let's say if it is very large, then what will happen? We may diverge, right? So what they have derived that for particular data set, you can always find one alpha value which will not diverge, as well as which may skip the local minima if it is relatively small. But yes, if the local minima is very large, then it is difficult to achieve the global minima, and once again the problem of that local minima will be there. Fine. But in many cases, you can solve the particular problem still with the help of that larger alpha value plus the squared error loss. And so that's one interesting observation that that they particular paper was having, right? So I hope it is cleared. And in this linear, with the linear regression, we have discussed that the impact of alpha, right? And in the laboratory also, many of you have observed, right? If you keep that alpha value very large, then what was the scenario that I hope you can recall. Fine. So that was just an additional stuff. So we'll stick to this current discussion where we have this loss function, that is the cross entropy loss. We are initializing the dw and the db bias as well as weight. Initial value of j, let's say 0, alpha 0.1. And now just go through this code and tell me if you found some difficulties in this particular code. So let me just tell you what I am actually doing over here. For 1000 iteration, I am repeating the steps, and the steps are calculating the hypothesis, the second step, that is calculating the loss, the third step, the calculation of gradient, and fourth step, updation of your parameter. Fine. So 1000 times, or you can say for 1000 epoch, I am repeating the steps, and just observe this particular answer. So in this laboratory, this basic version and the TensorFlow based version, this all I will try to cover, so that in the next laboratory, most probably I will uh, come with one particular NLP application where we can use this logistic regression, right? So we may speed up the concept, and we'll try to cover the basic version, sklearn version, and the TensorFlow version in this laboratory itself, so that in the next laboratory we may discuss some additional application which might be an interesting application for you, right? So NLP based application where we are going to classify the data using this logistic regression, and so I will discuss one of the application. Shall we continue? And now observe this W value. So we have two feature. So we have two different W values. So from this W values, can you tell me which feature have the higher weightage, higher weight? Age value, right? Compared to the salary, age have the higher weighted, though the difference is negligible. But yes, right now we just have two features, so accordingly you can find. So let's say if you have many features, you may find for particular feature, or you can say for which feature your algorithm is considering that feature as an important one, and accordingly it will weight that feature with some larger value of W. And next we are just predicting the result. And recall that in the prediction we'll have a probability value. Fine. So there is some value, the fractional value between 0 to 1. Fine. And we are setting our threshold to 0.5. So if that prediction is greater than that, then our class level is 1. That means by computer. Otherwise, the class level is 0. So once again, this 0.5 is a parameter or hyperparameter. Hyperparameter, right? And you can modify the code, and you can also add the regularization term. Right now we haven't included the regularization, but you can just add that regularization in all the calculation, right? So accordingly your equations will change. Otherwise the process will remain same, but the equations that we have used right now, it will be changed. Fine. And with this prediction, so y pred indicates the predicted values, and some results are shown. Next, with that prediction, you can calculate the accuracy. Manual means everything manual, right? So the accuracy calculation, once again, we are just checking all the elements one by one, whether the accuracy which we have predicted is same to the original one. If yes, we'll increase the count. And at the end, we'll see how many values are correctly classified, right? And that actually the accuracy is. Out of total examples, how many correct classifications we have. Fine, easy. The first version, we can say the first manual version. Okay, so if you feel that it's an easy version, then yes, definitely it's an easy. But if you feel that it's not an easy version, then the next version is there for you. That is, let's say, using sklearn library, let's try to implement the same thing. We are initializing the logistic regression function, which is available in this sklearn linear model. We are setting the random state to some same value, let's say the 0. હવે બધાનું કામ બરાબર છે. સોરી ફોર દેટ ઇન્ટરપ્શન. તેનાથી એક ફાયદો થયો કે જે જાગતા હતા એ તો જાગતા જ છે, પણ જે સૂઈ ગયા હતા એ પાછા જાગી ગયા બધા. Okay, so now the next is fit. So you need to just supply X train and the Y train to the fit, and to predict we'll supply X test. And done. Only 3 steps. And I hope you guys remember this fit and predict function, right? And next you can use this accuracy measure and you can just calculate the accuracy of prediction as well as the original value. Right, so just try to complete this implementation, this logistic regression using sklearn as well as the normal version. I'm keeping this slide open, and maybe after 10 or 15 minutes we'll discuss the TensorFlow at the second file. The submission link for this lab 6 is already mentioned in the given sheet, so you can just refer that link, and you need to perform this logistic regression on some predefined data set using the PyTorch. And I will discuss this TensorFlow, and you are supposed to implement this PyTorch version. For laboratory number 1 up to the 5, the evaluation is already done, and some students are not submitting the laboratory on time. So make sure that you submit it on time, even if the form is open after the 6. But as you all know that the Google form also record the times, right? So if your submission is after 6, anyhow, it will be considered as a late submission. So make sure that you submit it before the deadline, or maybe at 5:59 at max, right? Sachin છે Sachin. So what's your current status, Sachin? Will you submit it from this particular laboratory, or have you discussed it with this sir?
Hello, sir.
Yes, Sachin.
Yes. So now I haven't discussed anything, but yeah, I'm first trying to submit the previous labs, and then I will cover the current.
But the previous lab, the submission links are already closed, so you can just mail that submissions to me. And
Yes.
what I advise personally, that you should try with this logistic regression first, and then later you can complete the previous laboratory, right? Because there is a very less dependency between the current lab as well as the previous laboratories, right? So make sure that you submit at least this laboratory from this laboratory on time, and
Okay.
also before the final submission, at least you can submit all the previous tasks.
Yes, sure. I will mail you for the previous submission.
Okay, okay, Sachin.
Yeah. Thank you.
So I hope you all have completed this logistic regression, the implementation, both the version, that is the first manual version and this sklearn based version. And now we'll start discussion of TensorFlow version. And for that, we'll use the MNIST dataset. So if we just begin with the discussion, in the previous semester, I guess one or two group have tried this MNIST dataset. Where we have digits, and the good thing is the data set, that's an image based data set where the digits are represented as an image, where the good thing is the images are of size 28 cross 28, right? And whenever we say pixel, or you can say whenever we say 28 cross 28, that means that many pixels we have, and each pixel, for an individual pixel, the range is between 0 to 255, right? That you can say the intensity value, where 0 means which color? I guess from the image processing you can answer this question. Black, right? Where 0 means black and the 255 means the white, right? So that values, or you can say that gray shade values we have for different words. So you can just look at this MNIST data set, and you may see different digits, right? Maybe within this program itself. So let's begin with this TensorFlow. First of all, we'll convert that value to the float. Next, we'll normalize the values between 0 to 1, right? And then we'll convert that 28 cross 28 into one-dimensional space. Right. So just imagine that you have 60,000 examples. In a training, you have 60,000 examples, and individual example is one image, and the size of that single image is 28 cross 28. Fine. And now on this data set, we are supposed to apply the logistic regression. Fine. But if you just recall the logistic regression, what we are generating, we have the data in Excel where we have some X values and one Y value. But the scenario is a bit different over here in this practical application, where you need to classify a particular digit, the handwritten digit, which is present in the MNIST data set. So for that, the scenario is a bit different. Now you do not have different X values for different examples. Instead of that, you have 28 cross 28 image, and we have such 60,000 images. So the first step that we'll do is we'll convert that 28 cross 28 into a flat, or you can say into one-dimensional array, which is actually a 784 features. Are you getting where one individual pixel is one single feature? Fine. In total, we have 784 such features per example. So now compare this data with the previous data, right? We just have two features, x1 and x2, where the x1 was age and x2 was the salary. But now instead of this x1 and x2, now we have x1, x2, x3 up to the x784. For individual pixel, we are considering individual pixel as an individual feature. So what will be the size of your X matrix? From this given description, can you identify what will be the size of X matrix, and parallelly also identify what will be the size of Y matrix in a training set? Right. So for the X, the size is 60,000 cross 784, where we have 60,000 examples, that many rows, and 784 features. So per example, we'll have 784 features. For the Y, the size is 60K cross 1, right? How many different values we have in the Y, or how many classes we have? 10 class, right? Where each class is related to individual digit, 0 to 9, right? So it's an example of multi-class classification. The previous version that we have seen, that is by computer, was a binary classification where we just have two class, by computer, yes or no. But now it's a multi-class classification where we want to identify, once we have the test image, once our model is ready, and once we have the test image, so for the given test image, we want to identify in which class it belongs, or in other terms, you can say we want to identify which digit it is, whether it's 0, 1, 2, or it's 9, right? So that's the goal over here, and for that purpose, we'll use the MNIST data set, and we'll also use the TensorFlow, right? So just consider this example, right, where we'll try to apply this three step. First, we'll convert it into the float, then we'll normalize it to between 0 to 1, and then later we'll flatten it to the one-dimensional array. So X train, Y train, X test, Y test. From the MNIST, we are using this load data set. First of all, import this all necessary libraries. And also from this Keras, there is tensor for Keras, import the MNIST dataset. Next, to convert it to the float. No, it's not available on drive, so you have to code it. To convert it into the float, we are using this numpy library, right? And we are using this numpy array. And we are converting X values to the float. And using this reshape, we are changing the dimension, and we are considering, or you can say we are converting it to the 1D entry. That's instead of this 28 cross 28 matrix, now all that entries will be represented, all the 28 cross 28 will be represented as a row vector, and the size is 784, which is nothing but the multiplication of 28 cross 28. It's one by one. All that 28 rows we are packing together, and we are considering, or we are generating one single row. And next, normalizing it by dividing with 255. Right? So run this cell, and it may take some time as there is a need to download this MNIST dataset. So it may take few seconds. સાથે છો બધા? Okay, so now I hope you have loaded this MNIST dataset, and also you flatten it out, and now it's normalized image, or you can say you have X matrix of size 60K cross 784. So these two are the additional steps, right? Previously, there was no need of performing these two steps as our sample, or you can say our examples, which are examples that we had were given in the form of Excel itself. That means in the form of feature as well as the Y label. We just need to separate it out. These are the X values and this is the Y value. Right? But now we just have the image and the class label. So for the X values, we'll treat it as an one single row. We'll convert it into the one single row. And for the Y values, we have a single row. We have a single column where some numbers are written. That number is actually basically between 0 to 9. So what we'll do with the Y? Okay, we'll see later. We need to perform some operation on Y2. So we'll see what exactly that operation. Fine. So our X is ready. Okay, yes. Before moving forward, this is an example of image. Previously, we have seen the pure data, and now consider the third case. Let's say text data, and you want to classify the text data. So once again, if you want to apply this logistic regression classification, you need that Excel kind of scenario where you have some X values and accordingly you have the Y values. So for the text, how will you convert that text data into that Excel format, right? Where something cross something X values and something cross something Y values. So from this, from the previous laboratories discussion, can anyone recall how can we convert the text data into this kind of format? Right? For the image, we have seen that you can just flatten that image out, and that will represent the feature. What about the text data? Word vector, right? Or we'll use the terminology like embedding, right? Using embedding as well as using padding will convert that text data into this numbered form. Fine. And why padding is not necessary over here in the image data set? You may generally never find this padding with the image data set. Correct. So all the images that we have are of same size, that is 28 cross 28. And once again, remember that this is not a real world scenario, or you can say this, you can say filtered out images. Right? Generally, let's say if you want to implement this particular MNIST data set, so let's say you collect the images maybe via your phone. So maybe all the images that you have are of different size, as well as the word, or you can say the character or a digit which are located inside that image might be a different position. Right? So this is very noise free data set where we have 28 cross 28 images plus all the characters or all the numbers are located at the central, or you can say at the central point, approximately at central point. Fine. But if the scenario that I have just discussed, is it that scenario is there, then you have to perform some pre-processing on that, and then later you can apply such algorithms. Fine. So always try to map whichever discussion that we are doing, always try to map it with the real world scenario. And that's why what I'm trying for a individual algorithm, I will just discuss the basic version, right? Let's say if you consider logistic regression, we just discuss the basic version, then we'll try the sklearn. And now with the TensorFlow, what we are trying with the MNIST. So one important pre-processing task that we have identified over here is we need to flatten that particular images. And similarly, depend on the data set, once again the pre-processing task will change. So now if we move towards the third step, where we are supposed to initialize the parameters. So we'll have two things. One is number of class. So we have 10 classes where the values are 0 to 9. Each class is related to particular digit. And number of features are 784. So some values that I'm setting: learning rate 0.01, training step, just set it some smaller value. Otherwise, maybe after 5:30 you will continue with the model training, right? So just set smaller number for the training step. Right? The batch size, it is actually dividing your training data into different batches, and for batch we'll try this particular algorithm, right? Recall the linear regression where we have discussed the batched version of our gradient descent. And this display step, what is the role of this display step? We'll see lateral, so you can just consider it as it is. Or let's say over here, if you consider training step 100, then consider the display step as 5. We'll use that value to display the answer after every 5 epochs. Fine, so just set it to 5, right, and initialize all these parameter. And also read the description of this step 4, and just recall previous laboratory where we have discussed this shuffling within the batch, as within the batch shuffling. Train test split, it will definitely shuffle your data with the help of that random seed, but within the batch also we are supposed to shuffle the example for different epoch, right? And the reason we have discussed in the previous laboratory, right? So the next step will be that shuffling. And so just try this code and also read this description. So just these two steps, if you want to shuffle the data in TensorFlow, only you to try these two steps. First, we are taking the slice from the full training set, that is X train as well as Y train. And remember that whenever you are shuffling the data of X, do not forget to shuffle the Y also. Otherwise, what happens? You map different image with the different answer, right? So your Y, the correct Y values are invalid. Next is we are initializing weight and bias. Remember that, and okay, we'll see what is the role of this variable. But before that, just consider the inner portion, the inner code, where we are initializing the weight by number of feature cross number of classes. And then the one values, the weight values are 1. I hope you can recall the equation. The dimension of theta. Okay, what will be the dimension of theta? Let's just recall, right? What will be the dimension of theta for this example? That is number of feature time number of classes, right? Where the number of features that we have is 784 and the classes are 10. And so that will be the dimension. Fine, and we are initializing it with 1, and we are initializing the bias with 0. And once again, that's not the thumb rule that we have to initialize weight by 1 and bias by 0. Right? You can try 1 at both places, or you can try 0 at both places, and so on. Right? But the interesting point that I want to highlight over here is this conversion of this 1 or 0 matrix into a variable. So in the TensorFlow, there is one term variable. So you need to convert your tensors into a variable if you want to perform the automatic gradient descent calculation, or you can say if you want to perform automatic partial derivation. And so for that purpose, you need to convert it into the variable. Can you recall what was the step with the PyTorch? If I want to perform the gradient, I have to specify something. From the last laboratory, can you recall that what you are supposed to do? Right, we need to set that required gradient to true. And in this case, if you want to perform that automatic calculation of the gradient, you have to convert your data into a variable. And so, or rather than, you have to convert your tensors into the variable. And so we are converting weight and bias to the variable. And now, next we'll define the logistic regression and our cost function. So in this logistic regression, we know that we have to apply theta times x, or you can say the multiplication of x and w. Remember that the w, we are using this term frequently or interchangeably. It's theta and w. So this is the inner part is weight multiplied by x and plus bias, and on that we'll apply sigmoid function. Right? But now instead of sigmoid, why I have written this softmax over here? Why I haven't written that 1 upon 1 plus e raised to minus and this inner part, that is in this multiplication? Why I have written the softmax? See the comment if you get some idea from comment. So if you recall the lecture discussion, when we have, okay, for the sigmoid function, the output value is between 0 to 1, right? And the probability value is between 0 to 1. And we know that there are two classes. So if one is, let's say the output prediction is 0.2, the other will be 0.8. But now instead of 2, we have multiple classes, right? So if you just recall the last slides of our lecture, yes, Akshay, correct. So for all the classes, now instead of that, instead of calculating that simply sigmoid, what we'll do, we'll find the weighted average of that, right? And that's nothing but the sigmoid. So that the summation of all the probability will be 1. So for individual value, or you can say for all the y prediction, you will have 10 different values. Y prediction will have 10 different values, and and that 10 probability values, the summation of all 10 probability values will be 1. And that's why we have used the sigmoid. Sorry, that's why we have used the softmax. And once again, the softmax is also very important activation or important last layer in the case of many classification algorithms. Fine. So one problem or one issue at this point with the softmax, we'll get 10 different values for a single example, that you can say 10 different probabilities for single example. And how many y values we have? Just one. Right. So if you now observe this cross entropy function, or you can say cross entropy loss, first of all, whichever is the true value, we are converting that value into the one-hot vector, right, where the depth of that one-hot vector is number of classes, that is 10. Are you getting why we are converting it to the one-hot value? So that is the first point. The second point, this is most probably the not very much important point from all the examples perspective, but many time you may stick to the log 0. Right? In the lecture, remember that we have discussed that the logarithm may leads to the infinite. And so practically, in lecture we have also discussed that in a practical, or you can say in a laboratory, we will discuss that what should be the solution for this. Right? So the solution for this is you can use the concept of gradient clipping, or you can say just a clipping rather than gradient clipping. You can say it's clipping. And so if it go beyond some value, we'll reset it to avoid that infinite value in the answer. Right? And at the end, we'll compute the cross entropy loss. That's over here. This step, the first step is important, where we have converted the true y value into one hot encoding. That the second step is to avoid that log 0. And in the third step, actually, we are calculating this cross entropy loss. And recall that there are two terms. One is max and the one is the argmax. So for individual example, we have 10 different probability values where the summation of all the 10 probability is definitely 1. But during the prediction, we need to consider one of that value as an answer. Let's say that 10 values are 0 0.1, 0 0.1, 0.1, and whichever is last, that might be some larger or the higher value, right? 0 0.1, 0.1, or let's say some other values, but one of them is a larger or the higher value. So that should be your prediction result. Fine. So now what we are considering for the prediction that you have, we are taking the argmax of whatever is answer and 1. Oh, sorry, from all the probability, whichever is the highest. And from this, you will get one number. Let's say the number or digit is 5. This is the representation of true value. We're just converting it into the integer. So we'll identify how many such samples are same. Right, and accordingly we are calculating the accuracy. Once again, this is a manual calculation. If you want, you can directly calculate that accuracy with the help of function by supplying the y prediction and the y true. But make sure that on the y prediction you will apply this argmax to get a single value. So now the things are very easy. Gradient we are not supposed to calculate. It will be calculated by TensorFlow, right? We have already defined the logistic regression. We have defined the cross entropy. So first, by applying the logistic regression, we'll predict some result. Next, to check how much accurate my result is, I will supply that prediction in the true value to j. That is actually the cross entropy function, right? And we'll calculate the loss. That is j. Next, we'll use the gradient on a loss and we'll try to update w and b. That's it. You just need to write this step. If you want to calculate the gradient, you just need to write this step. No need to write the equations, right? On your behalf, that partial derivation will be performed and the gradient is calculated. But the important point that I want to mention over here is this g. That is from the gradient tab. Right? And you need to wrap your computation within that for automatic differentiation. Right, and now we are using the SGD algorithm with a given learning rate. This is a hyperparameter that we have set. And next is applying it to the result. That is using the apply gradient. Fine, so now the optimizer function is ready. Next, you need to run that particular optimizer. And now recall this display step. We have set it to 5. Right? So after all 5 iteration, we'll predict the result as well as loss and the accuracy, and we'll display that values. And in my case, I have executed it for 1,000 times. So over here, you have a result for 1,000 iterations. That's in my case, the step size was 50. Observe the initial loss and initial accuracy, that is 0.72. And at the end, the change into the loss value and the change in the accuracy value. Also observe that in between, at some point or at some time, the accuracy value may decrease, or you can say the loss is decrease. Because now we do not have 1D or 2D or 3D space, but right now the dimension is 784, right? We have X dimension that are 784, and accordingly at every iteration, the gradient updation will change all that 784 parameters. Right? So let's say the incorrect value, or you can say the wrong value of particular parameter, the single parameter, may lead to a wrong direction, a very slight change in towards the wrong direction. But eventually what happened after the next or next to next iteration, once again the gradient, or you can say the loss value, will become larger. So the gradient descent comes to know that this is the wrong direction and it will change the direction. Fine, and we are just calculating the accuracy values by using the accuracy function that we have designed. Okay, so this is a single exercise for you guys. You need to try this logistic regression on by computer dataset that you already have, but now with the help of PyTorch. And once again, we'll come with that rule that you have to set random state is equals to your roll number, or if you do not have the roll number, the last 3 digit of your ID. So now try to complete the remaining code, and if you're done with that, just recall this task, that is you need to consider this by computer and the PyTorch, and do not forget to set random state is equals to the roll number. Fine. So there is only one task that you need to submit as for the submission of this laboratory. Any question? In the step 9, we're just calling this run optimizer, and this is just for the printing purpose, right? If you want, you can just ignore that steps, or if you want, you can just print that answer for all the steps from 1 up to the 100 or 1000. Haven't you completed that, Milan? Any particular code or any particular cell is missing, or any particular step is missing? Okay, so we'll share this file, right? I will just upload this particular code on the drive. So I hope this TensorFlow version of the logistic regression is clear, and it is very essential from the machine learning's perspective that you know the basic version, that is implementation from scratch, as well as you know how you can convert your code into TensorFlow, or you can say the PyTorch version. And so that's why we have discussed this both thing, and in many laboratory we'll try either PyTorch or the TensorFlow if possible, right? Previously we have tried the PyTorch with the linear regression, and in this laboratory we have tried the TensorFlow, right? And previously you have implemented TensorFlow, now you have to try the PyTorch version of this logistic regression and our data set, that is by computer. So with this, let's conclude this session. Hope you have enjoyed this session, and have a nice day. Thank you.